This is part 4 on the Triarchy vector signal generator, the VSG6G1. What I'm going to try to do now is to set up an FM modulation. I will start by going to mode. Of course, I've already loaded the software and connected the USB. So we'll go up here to mode. Let me see if I can add a little better in the picture. Mode is up here. We'll click on that, and then we will click here on single frequency without pulse modulation. Then we will pick a frequency, and in this case I'm going to pick a start frequency of 1.5 gigahertz. Then I'm going to go to amplitude, and I'm satisfied with an output level of 0 dBm, so I'm going to click on that. Then, if you remember, you have to set the I and Q right here to internal before you can apply any modulation. Then we're going to choose analog modulation, and we'll load the demo FM. And then if you look over here, and I'm not sure how well this is going to show up, but the blue trace, that is this trace, is the I signal. The green trace, this trace, is the Q signal. And what this demonstrates is that using a quadrature modulator, by having two signals, in this case slightly out of phase, you can produce frequency modulation. Now we'll look at that in a little bit on a spectrum analyzer, but for right now simply realize that the I signal and the Q signal, when they differ in phase, produce a frequency shift in the carrier. Now let's go over and look at the spectrum analyzer. I've switched to the Instec spectrum analyzer, and in case you haven't seen the spectrum analyzer videos that I did a year or so ago, this is one of the spectrum analyzers that I used in that series, and I also gave it a kind of a review at the same time and compared it to the Rigol. This spectrum analyzer, unlike the Rigol, will go all the way to 3 gigahertz. So I'm able to display a 1.5 gigahertz waveform easily on this one. And let's zero in on that display, and you will see what an FM signal looks like. Now, an FM signal consists of a carrier and a series of frequency modulated sidebands. In other words, unlike an AM signal, where if you apply a single tone, you get a single upper and a single lower sideband, with FM, you get a whole series. And if you watch the spectrum analyzer series, you know that those sidebands are according to a series of Bessel functions. Won't get into much detail here, but basically if you want to calculate the size of each sideband, you can do that either with a graphical or table method that I showed in the spectrum analyzer series, or by using Bessel functions. They're not as complicated as they sound like, but since most people have never seen them before, I'm going to stay away from that in this video. So nonetheless, this shows that we have an FM signal with at 1.5 gigahertz with proper sidebands. Now what I'm going to do is I'm going to change the frequency to 2.5 gigahertz. And here you see the spectrum. And I'll point out something else that I've done. The cable that is connected here to the generator is LMR 400. The cable that I have been using, the little small RG58, is perfectly appropriate up to about a gigahertz or so, but when you get above a gigahertz you really need to go to better cable. So this LMR 400, it's kind of stiff and hard to work with, but it sure is a lot better cable at these frequencies. And this is one of the reasons that I bought this Triarchy generator, was to generate signals in the 2.5 or 2.4 gigahertz range. As you probably know, the most of the 802.11 signals these days are in the 2.4 and the 5.8 gigahertz bands, like 802.11an and so on. It won't be long until even a 6 gigahertz generator will be obsolete. But at any rate, here is the FM spectrum, and it's not bad. But I do have to say I have seen better. But then for a $400 or $450 spectrum generator, vector signal generator, this I think this Triarchy does a pretty good job. The other problem, of course, is that at these frequencies you start running into issues with things like your measurement equipment as well. And while I have compared this Instec to the Rigol over the frequency ranges that they share in common, in other words up to 1.5 gigahertz, I've never looked at a signal this at 2.5 gigahertz like this one on the Instec before, but it does appear that it produces a reasonable representation. Now what I'm hoping to be able to do is to take this Triarchy generator and run it on a lab grade spectrum analyzer so I can compare it, because as I've said, I'd like to do some experiments in the 2.4 gigahertz range, and so I now have both a spectrum analyzer and a vector signal generator that work in that range. So I think at this point I'm going to, at least for now, stop the series on the Triarchy vector signal generator, but at some point in the future maybe I will pick up and show some videos of the use of this generator to do some experiments, perhaps with simulating some 802.11 signals and things of that sort. Once again, hope you enjoyed the video, and hope you'll look forward to some maybe in the future. In the meantime, have a nice day.